Talk about a couple more projects. This is 33. I don't think I've talked about this one yet. I just got this one up, I think, within the last week. This is another game. You had another game like this with cards, where you pull cards and rearrange them in order. This one here is similar, but it's in a ring. And so you have cups, you put them in a circle, and they're labeled. They might be labeled out of order. There's a label on each cup which is not equal to its position in the ring. So 3, 2, 1, 4, 5, and if you go around back to 3 again, a loop of 5 cups. So now, before the game starts, your opponent, the first cup is designated as the current cup. And for each move, they pick up the next 3 cups after the current cup, remove them from the circle, and now they choose a destination cup by taking the label of the current cup minus 1. So in this case, they would pull out 2, 4, and 1, and the circle would be down to just 2 and 5, or 3 and 5. So they try cup 3. They will now try to find cup 2, but cup 2 is not in the circle anymore. Cup 1 is not in the circle. As you go down, you'll go to 0, then to 5. So 5 is going to be chosen as the destination. So it will take these 3 and put them after 5. That's it. And since it's a ring, you can start it at any point. And then move the destination, move the active cup forward 1. So that's the game. You change the new current cup, move it forward 1, which now would be 5. So here's some examples. If you start with this ring of 10 cups, the parentheses indicate the active cup. Cup 3 is active, and then you have these cups in this order. So you pick up 8, 9, and 1, and you move them to 2. 1 below 3, 2 is in the circle, so take those and put them after 2. So this is pretty obvious. Then the active cup moves to the next cup, which is now 2. So you end up here. Now, what's interesting about this, when I coded this, you can think it's right for a while and be wrong, and then you can think it's right again and be wrong. There are some subtle problems, and they're getting pretty closer. So here we have move 2. I have cup 2, so I pick up 8, 9, and 1. And now I have to put them at cup 1, but 1 is not in the thing anymore. 0 isn't there, so I have to go up to 9, 8, they're not there. I have to go to 7. So now you begin to see the problem. I have to put them off the end here after rolling it around. So that's going to be a little hard to implement. My first implementation didn't get that right. So the 8, 9, 1 is going to go after the 7, and then you have the 5 here. So 5 means you're going to pick up 4, 6, and 7, and you're going to put it go down from 5, try 4, but 4 has been picked up. Try 3, well, 3 is here, so you'll put it there. So now it's going to be 3, 4, 6, 7, 5. 3, 4, 6, 7, 5. Now, when I first made my program, it would print it out that way, and that is technically correct. But in order to be able to check by comparing to this, I had to add an extra couple of lines to figure out how to roll it around so the active cup would move just 1 to the right. So I can match this diagram. You can see that's the pattern here. They show it, so this move 1 has the cup, active cup at 1, and active cup at 2, and active cup at 3. So I was able to duplicate this stuff after several iterations. And there are some situations where it's tough. Now, the problem with my solution is the way I did it was at first I found it hard to predict where a cup is, at this point where you have to search for one, because you keep pulling cups out and reshuffling them. So I wrote an algorithm that would just do a search to find a cup from its label. And I call it many times. Like pretty much before I do anything, I call this to find out where the cups are now. Because one thing that really got me is there's a point where you're adding 3 and you're near the end, so you add, you're picking up 3. You pick up 1 from the end, now the list is shorter, you have to pick up from a different location. Now the list is shorter. So I have it, keep calling that routine to find the cup it's trying to pick up. And that, since there's only a list of 10 cups, I just did simple linear search, which is, by the way, the only thing you can do because they're not in order. But that had this effect. When I was done with this one, I simulated 100 moves, and I was able to predict the cups. That's easy enough. But the next one from the original problem was 1,000,000 cups. And I can't do 1,000,000 cups at all. In fact, I tried 100 and 1,000, and as I suspected, I discovered this. When I did 1,000, it took 2 seconds. When I did 10,000, it took 200 seconds. It's going up by n squared because I have to do about n operations, and every one of them requires listing that list. So the fact is, I'm sure if I'm more careful, I can just keep track of where the cups are without ever having to search for them. And that should improve my algorithm a lot. But right now, I can't get to 1,000,000. So I put in some central flags. I put in 1,000 and 10,000 cups. And the way I did it, this takes like 5 minutes to calculate, which is ridiculous. because I'm wasting most of my time with an inefficient algorithm. And remember, I mentioned this about previous challenges here. That's why these things are really useful for serious coders, because they get into the depth of how do you make it fast. And I haven't got there yet, but I'm hoping to add more extra credit portions to the end of these after I figure out how to make them fast. There's a couple of these that I know can be made much, much faster if you're smarter than I have been so far. So I just thought I'd mention that. This way you get to practice the important stuff, reading something, designing a data structure, implementing it, and getting all the bugs out. But the next step, which logically should also be in this course, is refining it to make it faster. And I'd like to add that, but I haven't got it in there yet. So anyway, that's what I wanted to say about this one. Let me check for comments. Okay, nothing new except the statement that a flag might be wrong, which I'll look into offline.